Alright, welcome to the video that's going to go over the exterior angle theorem for our triangles. So what the exterior angle theorem states is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So the main things we need to know how to do, one, we need to know what an exterior angle is. So we're used to seeing our three-sided triangles just like this of what I highlighted in red. Now, an exterior angle is formed when we extend one of those sides. So in this case, we're deciding to extend this bottom side to the left. And when we do that, we create this exterior angle here, which we are labeling as angle D. So once we know what an exterior angle is, we also need to know what the opposite interior angles are. Now the location of these depend on where your exterior angle is. So right now our exterior angle is D. Now what I need you guys to realize is that the angle that's right next to our exterior angle, this dark blue one that I'm highlighting right now, has nothing to do with the theorem at all. But what we need to do is go opposite or go across from our exterior angle over here to angles A and B, and those two are the opposite interior angles. So in this case, angle D, which is our exterior angle, is equal to the sum of A plus B. And remember, A and B were our opposite interior angles. Now, you might also see this, some questions might refer to it as remote interior angles, but opposite or remote mean the same thing here. So let's just go over identifying exterior angles and those opposite or remote angles. So in this case, we have triangle ABC, and now we are extending this bottom side to the right. So our exterior angle is this angle here, right, which is angle BCD. And then our two opposite interior angles, remember, we have to go, it's not this angle that's right next to here, it's the angles that are right across. So it's this angle and this angle. So our opposite interior angles are angle A and angle B. So then our equation, the equation that we can write using our exterior angle theorem, will say, hey, the measure of my exterior angle, which in this case is angle BCD, is going to be equal to the sum of my two opposite interior angles. So angle BCD is equal to the sum of angle A plus angle B. All right, next, this looks more like the example that we had in our first slide where we're extending this bottom side to the left. So in this case, our exterior angle is going to be angle EAB. And then again, here is our exterior angle. And to get our opposite interior angles, what we need to do is go straight across from where our exterior angle is at. So our opposite interior angles are angle B and angle C. Now the equation that we can write, we can say from the theorem, we know that our exterior angle, which is angle EAB, is going to be equal to the sum of our opposite interior angles, which are angle B plus angle C. Now we're only dealing with letters here, but if it was a case where we had stuff filled in, like let's say maybe B was like 2x and C was like 3x minus 15 or whatever, we can also have a measure for our exterior angle. I'm just making up random things like 5x minus 5. We can actually substitute these into the equation with the letters. So it helps just knowing where the equation comes from, and then depending on the question, you might have different expressions in there. All right, now we can also go ahead and extend this side here going upwards, right? Now in this case, what we have is our exterior angle is this angle right here, which is angle QBC. And then again, to identify our opposite interior angles, we would go straight across from where our exterior angle is. So our opposite interior angles are angle A and angle C. So then our equation, again, is just representing this theorem, right? Our exterior angle, which is angle QBC, is equal to the sum of our opposite interior angles, which in this case, we have angle A plus angle C. Now, it's just good to get in the habit of seeing these different types of diagrams because you want to be able to identify where your exterior angles are, no matter what side is extended. Now, this is a common question that comes up. Can this be an exterior angle? Well, remember, an exterior angle comes from extending one side of the triangle. Now, if we evaluate this extension here, or what we're saying is going to be an extension, we have to think about it. If we're calling this an extension, it should directly be extended from one of the sides, right? But this segment that I have here, segment BQ, is not coming from any side. The only three sides you can extend side AC, which we can do in blue. You can extend side AB, which we can do in this greenish color. And then you can also extend side BC, which we can do in this lightish blue color, right? So if you see, when we extend all of our three sides, we never get that red extension side that we're trying to figure out. So no, this cannot be an exterior angle right here. This is not an exterior angle. We cannot use the exterior angle theorem here because what the side that's being used to form the angle is not extended from our triangle. So no, we cannot use the theorem here. So don't get tricked in situations like this. Make sure, if you're using the exterior angle theorem, make sure that the angle is being formed from extending one of the sides of our triangle. Now again, you kind of saw this in my annotation, but you might see some type of complex diagrams. But again, when you're making your equations, it starts just by identifying, take it one step at a time. So for example, if you're given something like that, this is x, and this is 2x, and this is 3x, or whatever, even though your diagram is more complex, the same thing will follow. You should be able to notice, hey, I have an exterior angle here, right? And I know that my exterior angle is equal to the sum of my two opposite interior angles. Now, this is a random example that I just made up in my head, but the same idea follows even if you had something like this. If you had this, let's say you had like x squared, and then you had like 6x, and you had like 13 or something, you can still make your equations, right? And it might help to rotate your papers in this case. Totally up to you though, but just make sure you know the equation that you can make using the exterior angle theorem.